As a part of our real-time operating systems and application course, we have done this motion detection system. We are team snippers. Motion detector. Nowadays you can see them in many smart devices. They are a key feature of many ubiquitous computing applications. They continuously observe the behavior of the things and take action in response to them. This is performed using an accelerometer. Why accelerometers are used are because they are very tiny, accurate and low cost MEMS. So they could be embedded in any small devices and even wearable devices. In our cell phones, we have an accelerometer which senses the motion. One of the application it does is when you change the orientation of the phone from a landscape to portrait or so on, the view which is displayed on the cell phone changes. So all this is handled using an accelerometer. Then one more example we can describe is a pedometer, where it counts the number of footsteps of the user, and then it gives these many footsteps have been recorded in one day and so on. So for all these we require a motion detector. Primarily motion detectors are developed using an accelerometers. Now the overview of the project, what we have done is a very simple generic motion detection system. We have a microcontroller to which we are connected an accelerometer, and then we also have a serial communication port to the terminal. So if any motion is detected, you will observe that if a click is detected, you will observe a click detected or a shake is detected on the terminal. In parallel to that, you will also observe an LED pattern in the microcontroller. The advantage of this is it's very simple, generic and modular implementation. The system is designed using DEMO9S12NE freescale microcontroller. It has inbuilt analog to digital converters, then it has two LEDs and then two switches. It has even a serial port for serial communication and so on. It has a 64K memory. Then the operating system which we have used here is MUSI OS2. It is a very portable, scalable, real-time operating system which could be used for microcontrollers and DSPs. It can run a number of processors at the same at a time. It is preemptive OS, and we have also used an accelerometer for detecting the motion. Now we'll see how an accelerometer values are how based on the accelerometer values you can tell what type of motion it is. Generally there are two types of motion. One, it is a translational motion, and another one is rotational motion. The translational motion decomposition is based on simple idea. A translation starts with a tangential acceleration and then it ends with a tangential deceleration. So if you see here, this object is moved in the y direction, and then so the x and z, it is constant. There is no change in values of that, whereas the y, it increases and then it decreases. So there is an acceleration and then there is a deceleration. So this is the voltage which will be obtained by the accelerometer. Here you could see that x and z is almost constant, it doesn't vary that much, whereas the y value, there is a peak observed. There is both a negative peak and a positive peak.
Here we will see how to set up hardware for our motion detection project. For this we used one microcontroller called DEMO9S12NE64, and we use one accelerometer ADXL335. This accelerometer has 5 pins. The one VCC is connected with first pin of microcontroller. This first pin has nearly 3.3 volt output. The second pin, ground pin, is connected with third pin of microcontroller. It has nearly 0 voltage output. The three XYZ axis pins are connected with 10, 12, 14 respectively. This accelerometer gives analog output, and this 10, 12, 14 pins are ADC, an electro-digital converter pins, so it convert output in digital. And we used 9 volt battery supply, and one serial connector is used. The serial connector, one end is connected with DEMO9S12NE, and the second end is connected with CPU. This gives output on computer terminal. For this we use one software called Putty. In Putty we can see the output. The BDM connector is used to dump a program in microcontroller, and this is all set up for hardware. In next slide we will see the video which demonstrate you hardware setup. So this is our video. Let me start it. So as you can see here, this is the rectangular box is our microcontroller DEMO9S12NE64. It's plugged in with 9 volt battery supply. This is the serial connector. The second end is connected with CPU. Here on the other side, this is the accelerometer ADXL335. It has 5 wires connected with microcontroller board, and this is the PDM connection. As I said in previous slide, is used to dump a program from computer to microcontroller. And I think this all for our hardware setup.
Implementation of each task. We implemented the task in app.c file for demo 9S12NE using MusiOS2. Through the physical code warrior RDE, the source code was loaded into the flash using P&E micro BDM multilink. We implemented the following tasks: normal LED working, sending tilting information to the serial, switches are pressed, read the potentiometer values when changed, detecting shake and click movement. When there is no input from user and code is working in the microcontroller board, then normal LED working should be LED 1 will blink after 2 seconds and LED 2 will blink after 4 seconds, and simultaneously the tilting information will be sent to the terminal. In this video we can see the LED 1 is blinking after every 2 seconds and LED 2 is blinking after every 4 seconds. And the outputs for tilting information, that is x, y, z coordinate values and pitch and roll values, are sent on the serial terminal. When we will change the position of the board, the values of tilting information will change, and we can see that in this terminal output. When switch 1 is pressed, the message will come on the terminal that switch 1 got pressed, and similarly for switch 2 also. When switch 1 is pressed, it will get detected that switch 1 is pressed, and when switch 2 will get pressed, the output will pop up on the terminal that switch 2 got pressed.
Here, when a potentiometer value is changed using this knob, the current value should be displayed in the terminal. Ideally, even there is a change by one value, it should be displayed, but we have designed it such the way when the value changes by plus or minus 3, then only it will be displayed. This is because even though when you don't turn on this knob, still there were some fluctuations. So in order to avoid that, we gave that if a user turns the knob um, more than 3 values, then it would be observed in the terminal. Then click, as it was discussed before, how a accelerometer detects a motion. Here for a click, there will be a great change in value in the z direction, whereas a very mild value in the x and y direction. So when that pattern is observed, it will be detected that it is a click, and the following LED pattern will be observed. It will be like some sort of blink over here. And then for shake, it is like there will be a variation in all the three directions. So when there is a considerable change in all x, y and z values, then it will be detected that it is a shake. Now we'll see how we can relate this project to our Rtos concept. Through this project, we could relate some of the Rtos concepts such as task, scheduling of task, and then assigning priorities of the task, and then based on the priorities, how each task is handled, and so on, and then synchronizations of the task, like that. Now in this project, for each functionality has been done as a separate task. So now each task could be given a priority, starting from 0 to a maximum priority. The scheduler ensures that the task in the ready or running state will always be given the processor. So the one with the high priority will be given the processor first, rather than which has a very low priority. Here the accelerometer values have been read continuously, whereas a click and shake, it will be detected immediately when there is a change in the value, reasonable change in the value. So when a click or shake is detected, then it should display immediately in the terminal, and then the following LED pattern also, so that task is given a more priority, and so on. While giving the priority, you should see such that it doesn't affect the performance of the system. And then we then faced one more problem, the reader writer problem. The accelerometer continuously keeps on reading, and then it updates the x, y and z value, so it's like something it's writing. And then the motion detector task will keep on reading it to check if there is a change in value. So we should make sure that these both doesn't happen at the same time. So to avoid that, we have used a semaphore. And then a memory also is taken into consideration over here, as it is a 64K. We should make sure that we use the memory effectively. So now we could see some of the applications which have been developed based on this motion detector. Lots of security systems has been developed based on this. We could see, like, if a window is broken, an alarm will be on, and like that, security systems have been developed using this motion detector system. Then, as I explained in first slide, in mobile phones they have been widely used. They have been used in a lot of games and so on. Thank you.
Now in the last we will see our entire project in one video. This video contains each and every task I will demonstrate you. As you can see here, the accelerometer is connected with microcontroller. 9-volt battery supply is connected, serial cable is connected, BDM connector is connected. So all the hardware setup is properly done. Now let's start this video first. So we used code warrior, the start debug to compile the code. It takes like 2 or 3 seconds for compiling, debugging the code, and it shows the message that correctly executed, means no error, good to start run, and the press run button, so it shows message that started running. So the program is properly dumped in the microcontroller. As you can see, LED pattern is in initial condition, and at the serial terminal, as we said before, we use putty to see a serial output. So let's start putty. As you can see here, XYZ roll pitch R value is coming, and this is the initial condition. Let's start with switching task. Press switch 1, so it shows switch 1 pressed, and then see switch, press switch 2, so it shows switch 2 pressed. The next task is potentiometer, so she is just moving potentiometer knob, so it value is changing. It shows on serial terminal. So switch and potentiometer is good. So you just remove BDM, we don't need anymore. Click task, so serial terminal, so click detected. So, and the LED pattern is also changed. Let's do it one more time. Yes, LED pattern is also changing on microcontroller, and serial terminal we can see that click detected. And this is the shake task. Yeah, the LED pattern is changing, and at serial terminal we can see shake detected. And this is the end of our motion detection system project. Thank you so much for watching.